Again, this is Jay Hafner on the Kenix Catamaran retrofit. It's a Genie Green electric, and we're here talking to Jeff Lemons, Hammond Air, and he's going to explain to us the history of DC air conditioner in his world, and DC air conditioning, and where it started, where it's going, and where the future development in electric propulsion in boats, and also other different types of services that he provides. Hi, Jeff.
Good morning, Jay. I'm the developer of several brands of DC air conditioning. We have a water-based model called the Arctic Wave, the land-based model called the Arctic Breeze, and then we do a whole bunch of strange heavy equipment type models that we call the Arctic Wolf. The best place to start is where we started developing our 12 volt or 24 volt or 144 volt DC air conditioning. It was because about 8-10 years ago we started supplying air conditioning for things like fire boats, work boats, patrol boats. That was an engine-driven air conditioning compressor on an inboard diesel engine. Similar to the fireboat we see across the way here, the Miami-Dade fireboat actually has one of our air conditioning systems in it. Just happened to be here for a good segue.
Yeah, that really helps.
What started happening is the U.S. Navy started going from inboard diesel engines to outboard four-stroke outboard motors. So instead of inboard diesels, they'd put 3 or 4 250, 300 horsepower outboard motors on their fast patrol boats. It's very, very difficult to figure out a way of mounting an air conditioning compressor, an automotive air conditioning compressor, on an outboard motor. So we tried to find an available power source to run air conditioning for our Navy men and women inside the cabins of these patrol boats. One of the things that immediately came to light was that each outboard motor was producing around 90 amps of 12 volt power, meaning we had an abundance of 12 volt electricity available to us, and if we could find a way of efficiently running air conditioning off of that 12 volt power, we could solve the Navy's problems. And that's what we set about to do. We designed a system, very effective, very efficient, on water-cooled, using a very large electric motor running a small automotive-style compressor. We presented that to a bunch of our sales reps that cover all over North America for our various products. And they suggested to us that setup would be very good in transport trucks as an anti-idling solution for drivers on their rest periods to stay cool and comfortable and be able to shut the big engine on their transport truck off, saving tons of money on diesel fuel and maintenance, not to mention the pollution that's being reduced and the noise that's being reduced.
So do you have a unit that you can show and explain how that works?
We do. The demo unit we have out on the dock here, it's 24 volt, not 12. But
let's go out and look at that.
It's the exact unit that would go on a transport truck in a slightly different voltage. So let's go take a look.
The Genie Green electric catamaran, and we are at the Miami Boat Show. We've been here for 3 or 4 days, and we've had a lot of really good customers come by, a lot of excellent questions. And Jeff Lemons here, he's here to show us a little bit more about the DC 144, 24, and 12 volt air conditioning systems. So in continuation, Jeff, you were talking about where your evolution came from, the trucking market and your salespeople?
Yeah, Jay, so this is, I just put the lid back on, but this rectangular unit here in nice diamond plate aluminum is what goes on the side of a transport truck for most of our 12 volt on the road applications. The evolution to the boat systems was almost just simply a matter of changing a large air-cooled condenser for a large water-cooled condenser. Let me pull the cover off the box so I can show you the basic workings. It's
of the truck
identical.
unit, yeah?
Yeah, but it's all, other than the condenser, it's pretty much identical to what's on your boat right now.
So this what got you started. This is what you put on the diesel trucks. They can in the no idling laws throughout the United States.
Yeah.
They're able to use that, and they're kind of hooked up underneath, and you don't have those little tiny diesels running anymore, or big ones.
It's very quiet for them. No vibration. no pollution whatsoever. And even the small diesel engines now, in places like California, they have to have the latest pollution control equipment on those engines, which makes them very expensive, very high maintenance, and just a continual headache. Not to mention they vibrate, they shake the truck, they make a lot of noise, and they bug their neighbors. The trucks parked beside them as well. If they don't have their own diesel generator, they hear more noise inside their truck than the guy who's running his.
That didn't sound like a very good night's sleep.
No, there's better ways of doing it, and battery power is it. So what we've got here is we use a very efficient, large electric motor to drive a small automotive compressor. And what we've set that up is at a speed that compressor puts out the most cooling for the least amount of power draw. So everything we do is very simple and straightforward, very much like the air conditioning system in your car, but we've done everything we know how to do to make it as efficient as possible, meaning it draws the least amount of electricity to put out the most amount of cooling capacity possible. So this unit on 12 volt power will average about, and it usually averages about 400 watts of electricity per hour with a maximum of 600 watt power draw at 12 volts. And on that voltage, it'll put out over 10,000 BTUs of air conditioning capacity. The 24 volt model runs about 750 watts and puts out over 12,000 BTUs of cooling capacity. And your model on your boat, which is a 144 volt DC system, and it's water cooled like all the boats would be, puts out over 20,000 BTUs for a 900 watt capacity, or 900 watt power draw maximum. If you try to equate it efficiency wise to a standard 110 volt or 220 volt alternating current air conditioning system, it's about 1/3 to 1/2 the power draw for our battery DC powered systems as the AC powered systems. A gentleman told me the other day if we repowered his whole 65-foot fishing yacht with our air conditioning systems, he could turn off one of his two 29 kilowatt generators, and that excited him a lot. So the major components we have here are built-in evaporators, and we free blow the air out of these evaporators. We're not trying to push air through ducting. That's very inefficient. It takes more power and picks up heat everywhere the air goes. We mount these in cabinets, pointing into the cabins you want to cool, and blow the air directly into that cabin. Very efficient, very nice. We often cover these face plates in whatever upholstery or wood paneling that the customer may like, that matches his interior.
So a little bit like Pimp Your Ride?
Yeah, pretty much like that.
Show me the back of it too, and show me what it looks like on the back side. On the back side, basically what we have is explain those hoses coming up and what we're doing here.
With any air conditioning system, you have to connect the unit from the compressor condenser unit to the evaporator unit, the cooling section, with two hoses and a wire harness. So as you see here, the hoses and wire harness are very easy to run in a small space. You're looking at maybe 1 inch to 1.25 inch diameter hole that you need to run all that through. And you compare that to a 4 or 6 inch run for a insulated flex duct coming from a standard 110 volt AC air conditioning system now. Much simpler, much more efficient.
You don't have all the loss of all the air and the heat going through that pipe.
You're not wasting your air velocity, and you're not picking up energy. You're not cooling a cabinet where your flex hose runs through. You're getting all the cold air into the living compartment that you want it to be.
So this thing right here, let's see if I can get it without the sun. So this right here, this thing right here, the coolant's going through there.
Yeah.
And then the winds, and then the fan's drawing the air through.
The air is being drawn through, and just so you know, you never put cool into a room. You're always taking heat out. So what happens is our air conditioning refrigerant comes through this little valve and turns from a liquid into a gas. And that requires a lot of energy. So it takes the energy out of the air that passes through this coil. It's not putting cooling in, but it's taking heat out. So once you take the heat out of the air, it of course is very, very much colder coming out the other side because you've removed that energy from it.
Wow.
All air conditioning is doing is moving energy or heat from one location to another. So we're picking the energy up in your cabin and we're getting rid of it with a water-cooled condenser, and it's going over the side as hot water.
Okay.
In a nutshell, that's air conditioning.
So this tube down here at the bottom, this drain tube, is just to drain the condensation off of it.
Air conditioning, because of course it makes things colder, condenses moisture out of the air, which is one of the big pluses of it. You get rid of the humidity inside the room.
Okay.
Even without cooling the room, just removing a humidity from inside of sleeping quarters is going to make it infinitely more comfortable, for instance, for sleeping. So the dehumidifier aspect of an air conditioner is one of the most important things, especially on a boat where it's always hot and always humid, especially.
And also those trucks, as soon as they shut down the engine. So if I owned a rig, and I knew I had to start complying with the laws, okay, what would it take for me as a rig owner can I DIY, can I install this myself?
We've had a lot of people install this themselves. I've trained a lot of larger fleets, trained their mechanics on the installation of this unit. It takes them typically 4 to 6 hours to put one of these on a transport truck. A little bit longer on the boats because we're mounting multiple evaporators.
And we'll see that inside too. Yeah. But tell me about this thing real quick. I mean, I can imagine some of the questions as a truck driver, and I'm going to install this myself. It says I've got a couple of batteries, 2 to 4 batteries that I'm using to start my engine now. What am I going to add? What kind of battery power am I going to have to add to make sure I can sleep all night and not and stay cool and keep the humidity down?
Well, if we look at these batteries right here, there's just 2 of them we've got connected in a 24-volt series for running this demo unit on the dock. These batteries are a top-of-the-line absorbed glass mat, or AGM battery. They are very effective at starting a vehicle, and they're very effective at holding a large charge and being discharged and recharged a whole lot of times. And that's critical in this type of application. On a transport truck, what we do is we take out the 4 existing batteries in the truck and put 4 of these top quality AGM batteries in, and then in most applications add 2 more somewhere on the truck. You can put these batteries in the living space of any vehicle because they don't off-gas, they can't spill. In fact, if you wanted to, you could ship these batteries FedEx Air. Why you'd ever want to, I don't know, because they weigh 78 pounds a piece. It would be extraordinarily expensive. But what that tells you is they're not a hazardous good. You can mount these anywhere. You can mount them on their side, on their end. The only way you're not supposed to mount them is upside down. Other than that, they're very, very flexible in their setup application, and they make a great battery for the trucking industry. And as you know, in your boat, where we've installed 24 of these to run the electric motors, and they make a great mode of transportation battery.